So in class today, we looked at the example of a function from reals to reals with the rule f of x equals x squared. And we know, from a calculus setting, that the limit of x squared as x approaches 3 is 9. Right? And just translates this using the definition we saw should be, these theorems state the same thing. In different language. For all epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus 3, closed absolute value is less than delta, then absolute value x squared minus 9, closed absolute value is less than epsilon. Now, we showed a lot of scratch work to show the motivation of where things come from. I think that helped for how delta was defined, but here, I think it'll be also helpful just to see exactly what relied on what else. So this, instead of a proof outline, let's really call this a proof flowchart. I'd like to really visually demo what implies what next, right? So you've got here this for all, we're proving for all epsilon greater than 0. As we know, we should let epsilon greater than 0. Great, let's just put that in a box, good old flowchart, old form. So we've processed that part. Now what we want to show is this part here, that there exists. And of course, that's the more challenging thing, right? So yeah, we had some scratch work. Go back to the Zoom recording if you want to look at that. But I'll just say literally, processing this forward, the next thing is this, there exists delta greater than 0. So I'll just write here how we had let or defined delta. In class we had done that delta could be, should be defined to be the min of 1 and epsilon over 7. So let's just box this. And so first, I think it's actually totally reasonable to put an arrow from this to this. What do we mean by this leads to that? This leads to that. It makes sense because in order to define delta the way we did, it references epsilon. So it really is, this doesn't come from nowhere. It did rely on this. So the two things together, so 1 is greater than 0. Epsilon over 7 is greater than 0 because epsilon is greater than 0. So these two things together lead to delta is greater than 0. Of course, that was one of the requirements. If you need it, there exists delta greater than 0. Okay, but then the key thing from this is that delta, if it's defined to be the min of these two things, then delta has to be less than or equal to each of them. It's going to equal at least one of these, but delta should be less than or equal to 1. Delta should be less than or equal to 7. And the point really is, we've seen so many proofs where one thing leads to the next, leads to the next. We're actually going to follow two separate tracks, so visually you'll see this, right? Okay, now what we'll do is we'll suppose, okay, so we've processed this, right? Now we need to prove this if-then. So that means we should suppose this right there, right? And so that, how about write this here? Suppose 0 less than absolute value x minus 3 close absolute value less than delta. And this does not rely on this or that, but it does mention delta. So in a sense, technically, it relies on this. Okay, so we take care of processing that. Now we need to prove this, right? That's all that's left. At the bottom of our proof, we have this fact. We're done, right? So this is all that's left. Maybe I'll just even switch and underline that in red. That's all that's left. There is some machinery that we need in order to get there, don't get me wrong. Okay, so what is it? From here, we get two facts. One of these we're not going to actually use, but I'll just mention it. It's 0 is less than the absolute value of x minus 3. That, it's true, we're not going to use it. But this fact right here, we have 0, the other inequality, absolute value x minus 3, close absolute value less than delta. This we're going to make use of. And here's the thing, we're going to make use of it twice. So check this out. This combined with this. So I'd like to follow this track here. From delta is less than or equal to 1. Combined with this, we have absolute value x minus 3 is less than 1. And see, if that's true, then the distance between x and 3 is at most 1. That means that x is stuck between 2 and 4. That's 2 and 4 are the numbers that are 1 unit away from 3. Okay, so part of the arrow drawing here is to make sure we know which thing led to what other thing. It's not looking at anything else. Just if this was true, we should have that. Right? And then if you add 3 to all three sides of this inequality, you have 5 is less than x plus 3, is less than 7. And x plus 3 happens to be bigger than 5, so in other words, x plus 3 is positive, meaning from here, you don't change the meaning of things just by putting an absolute value around the x plus 3, because it was positive anyway. So we've got that. Okay, and then, you know, you have two separate things here. You know, 5 is less than whatever. We're actually not going to need this, so left that little scribbly there. Absolute value of x plus 3 less than 7. Okay, great. So then let's go back. Like, we're pausing this for now. Like, here's this inequality. We'll use it a little bit later, but let's go all the way back up here. So by how delta was defined, delta was less than or equal to 1, and then we got this fact down here because of it. But also, the way delta is defined, delta is less than or equal to epsilon over 7, and then this together with this means the absolute value of x minus 3 is less than now. That's the stricter one. So less than delta, which is less than or equal to epsilon over 7. So we have this epsilon over 7. Okay. If you don't mind, I'm actually just going to take this thingy and just move it much further down. Right, so right, these two things lead to that. Okay, so we had this one track here. Like delta less than equal to 1 combined with this led to this. And then delta less than or equal to epsilon over 7 together with this same inequality led down to this. Remember what we were trying to prove was absolute value of x squared minus 9 is less than epsilon. So I'm going to just write down absolute value of x squared minus 9 down here. Absolute value of x squared minus 9. That is equal to absolute value factor x plus 3 x minus 3. The absolute value of product is equal to the product of absolute values. Like that. And then this first factor, as we have from this box right there, is less than 7. The second factor right here is less than epsilon over 7. So the result, this 7 cancels. So we have exactly what we needed. This is less than.